Look at the past year test 2 problem, okay, in your lecture notes. It is on page 6, okay. So I'll show you problem number 1, and hopefully you can proceed on your own for problem number 2 and number 3. All right. So problem number 1, use the definition of the Laplace transform to find the Laplace to the given function ft. So first of all, okay, read the problem carefully, read the sentence carefully. Okay, so in this case, it is stated clearly that you need to use the definition of the Laplace transform. So whenever you see the word definition of Laplace transform, so it means you need to refer to the integral from 0 to infinity exponent negative st times ft dt. Okay, because later on you will see in the later subtopic that this kind of problem can be solved by using a different technique. Okay, so read carefully. Okay, in the questions. Okay, if it is specifically asked for the definition, okay, use the definition, then you need to solve the problem by using the integral. All right. Okay. So the Laplace of ft, okay, is given by, okay, so we have two intervals. Okay, so we need to separate into two integrals. So the first one is from 0 to 3. Okay, so and then, okay, refer to this exponent negative st times ft. So in the first function, it is 3. So we have 3 exponent negative st dt. Plus, for the second interval, it is for t greater or equals 3. So it means it started from 3 onwards. Okay, so it means on the integral, okay, the limit is from 3 to positive infinity. Okay, and then we have exponent negative st times t. So normally we write the t first, and then we have negative exponent of negative st dt. All right. So for the first integral, that is a straightforward integration. So we have 3 exponent negative st over negative s. So if we evaluate from 0 to 3, but for the second integral, it is improper integral. So we have limit k approaching infinity, then the integral is from 3 to k t exponent negative st dt. All right. So for the second integral, look carefully. Okay, think of what is the technique, what is the integration technique that you need to apply. Okay, so we have t, okay, times exponent of negative st. Okay, so you can use by parts or tabular. So I normally use the tabular. Okay, but if you prefer the integration by parts, then you can proceed with the by parts. Okay, so if we take out that integral, so it means we have, this is by tabular, so we have positive sign, and then t, and then exponent of negative st. Okay, so this column we differentiate, this column we integrate. Okay, so change the sign, so negative, differentiate t is 1, integrate exponent. Okay, so don't forget we have over negative s. So careful here. Okay, carefully here, because sometimes students tend to write negative s, exponent negative st. Okay, so careful, you need to integrate, okay, for this column, not differentiate. All right, and then change the sign. Okay, so differentiate 1 is 0, integrate exponent, so you get exponent negative st over negative s times negative s, so we have s squared. All right, so back to the integral. So we have here negative 3 over s, I can put aside, okay, because Okay, we evaluate for t equals 3 and t equal to 0. Okay, so you can put aside, okay, negative s. So in the bracket we have exponent negative 3s minus exponent of 0, which is 1. Alright, so we have that. Now see what happened to the second term here. So the result of that integral, okay, by the tabular method is so positive times t times negative exponent. So we have negative t exponent negative st over s, okay, minus this one. So we have minus exponent negative st over s square, and we evaluate for t equals k and t equals 3. Okay, so we have that. So next, if we expand this, so we have negative 3 exponent negative 3s over s plus 3 over s. Okay, limit k approaching infinity. Okay, so now when t equals k, then we have negative k exponent negative k s over s minus exponent negative k s over s squared. Alright, so this is when t equals k, minus with when t equals 3, then we have negative 3 exponent negative 3s over s minus exponent negative 3s over s squared. Close the bracket. Okay, so now focus on the k approaching infinity. So we can see that for this one, when k is infinity, then we have exponent of negative infinity, which is 0. So this part is 0. The same thing goes to this one. Okay, k approaching infinity. So we have 0 here. Okay, so at the end, so we have negative 3 exponent negative 3s over s plus 3 over s. Okay, so we have plus 3 exponent negative 3s over s plus exponent negative 3s over s squared. And okay, we can simplify further because this one and this one basically cancel out. Okay, so at the end we have 3 over s plus exponent negative 3s over s squared. Okay, so this is the Laplace transform for the given piecewise function ft. Okay, so this is how we solve. So normally students were losing marks because of this integration, not really only formula. So student basically can know about this formula because basically it's given in the table of Laplace. So the rest is just solving the integral. Okay, so careful on the integral, careful on the positive, negative, okay, arithmetic thing and so on. Okay, so this is how you solve the piecewise function, finding the Laplace transform of the piecewise function. Okay, so for problem number 2 and number 3, you can try on your own. Okay, maybe you can check the answer for this one. So later when you attempt the solution, make sure you have this. So this is negative exponent negative 3s minus 1. So the solution for this one is slightly longer. Okay, because the function ft both involve the t. So 1 over s minus 1 plus 3 exponent negative 3s over s plus exponent negative 3s over s squared, where s should be greater than 1 in order for us to have a converged solution. So for this one, the answer should be 1 over s squared minus exponent negative s over s squared. So for this one, s should be greater than 0. Okay, so for the first problem, so this one also s should be greater than 0. Okay, so that's how you solve this kind of problem. So again, look carefully whether the question asks specifically for the definition or not. All right.